Let's go. Let's start solving some stuff. Let's go. Let's actually start talking about. Can you believe it? The derivative, like solving for a derivative, at least at a point for now. 2.7. No. In this section that we're in, we're just solving for at a point. We're not creating whole new functions yet. We're not actually using x's or anything. We're still using a's. So we're still using a's right now when we're going to be messing around with these derivatives. So, and dude, I forgot in the last freaking video. I got too excited. Hey, we got two formulas for this. Not just one. To find a derivative at a number a. Not to create a whole new function we don't have two of. But for finding it at a number a. So I showed you the difference quotient. All right, that was the last one. So we have this, and this is the one. If you just want to learn one thing, learn this. But then we also have this method too with the secant line. All right, instead of that, we can use the secant line. This is great for finding the derivative or the value or the derivative at a point A. It's good. It's good. Not the best for creating functions though, like in 2.8 or our next section that we go into. But let's go tackle a problem that asks us to go find the derivative at some point A. And the one we're about to do, this is silly. This is ridiculous. This is a ridiculous one for us to be doing. But I just want to show you kind of like where things go and how it, like just the notation without it being super nuts. Yeah, I'm asking you to find the derivative of a line at a point A. I'm going to tell you the answer right now. A is a number. A is just some number. It's some number that, like, I don't know, maybe like A would be 2. So it's asking, what's the slope of this line when x equals 2? I know that it says A, but it's actually saying x. Really? So I'm asking you, what's the slope of that line when x equals 2? This, oh, you mean the thing that's already a frickin' line? The slope is 3. I don't care if x is 3 trillion. The slope of a line is the slope of the frickin' line. And the derivative represents the slope of the tangent line. So I thought I'd just tie that together too. So the answer is going to be frickin' 3. This is a silly problem. We're not really doing much. I'm just showing you the two different methods now as to how we're going to solve this and like where things get plugged in. Now method 1 is my preferred method. I'm going to do the second method as well because your online homework uses it. So I'm going to show you one and then I'm going to do this other problem and I'm not going to do it the other way. So here we go. First one, let's look at method 1. So it's looking like we're going to have a few things we need to plug in. F of A plus H and F of A. So let's go find those two values right away. So let's write it right underneath our F of X. Because that's the F. That's our key. That's what we got to go play around with. We play around with this up here. So we're going to write it 3 times. And instead of writing an X, let's just write a parenthesis. And then let's look back inside of our parenthesis and go, what did we write? Oh, it was just A plus H. All right, cool. So we'll put A plus H in there. Well, we also have to find F of A. So let's write that down. So that's 3 times, parenthesis, and plus 2. And then we look back inside of our parenthesis because that's an A we plug in. Oh, neat. There's our 2. We got it. There they are. So we're just going to pop right in there for our limit. So the notation for method 1 is kind of jacked up. Huh? It's not very cool, but there's a good learning lesson through this as well. Just, I know what you're about to see, and if you want to make your life a little easier, try to understand this crap now. So we're going to do F of A plus H first. That's the top one right here. So we're going to write in 3 times A plus H, all plus 2. Now I'm going to put a bracket around it just to show you, like, that's your F of A plus H. And we're about to subtract out our F of A. And the number one most common mistake while doing this is sign error. So I'm going to make another bracket so then when we plug in our F of A, we don't commit sign error. And you mind if I just write it as 3A plus 2? And we don't need a bracket here. I'm just using a bracket because I used a bracket in the first one. You could use a parenthesis. It doesn't make any freaking difference. All we're making sure is that this negative is going to end up getting distributed into both places to where we don't commit sign error. So now, once you have it like this, the game is you're just trying to get this shit to not be 0. Well, the way you're going to make it not 0 is make it cancel out with something up top. And the difference quotient, there's something nice about it. There's pit stops along the way. All right, so what we're going to do at this point is we're going to take this, get rid of all the frickin' parentheses. And once you get rid of all the parentheses, if everything that doesn't have an H on it doesn't go away, you did something wrong. It's a cooked up game. It'll always kind of work out shit'll just fall apart. It'll go from like, oh, it's so much to, hey, where'd everything go? Because it's a cooked up game. Some badass geniuses back in the day figured all this crap out. It is pretty good. All right, 3a plus 3h plus 2. So there's that first one. Just got rid of it. Now we bring our negative into both. We get negative 3a minus 2. And now look. Come on, y'all. What's up? Minus 2, positive 2. Positive 3a, negative 3a. Whack. Everything goes away. It's all cooked up. Even on the giant problems. Like this is like entry level. Just kind of getting you used to it. They'll get huge. Don't get intimidated. It just starts canceling out if you're patient with it. So what are we left with? Oh, it's 3h over h. Those just cancel out. I think we're about done, huh? The limit is h tends towards 0 of just 3. Well, if there's no h's, then we don't give a shit about h, and the answer is just 3, because the slope of the line, 3x plus 2, believe it or not, the slope of that line is 3. We just showed that, because the slope of the tangent line at a point A is the same as the derivative at a point A. It's the same thing. Let's go. Method 2. So we're going to start plugging in. Like the limit as x tends towards a. We can just leave it as a. And our f of x. And our f of x was, let's go look. Now what is it? Oh, it's 3x plus 2. So we pop that in. And now we need to subtract out our f of a, right? There it is, that f of a. But we found that from before. That's just 3a plus 2. It's just replace all your x's with a's. Replace all your x's with a's. That's all that is. F of a is saying just the first thing you wrote. Don't write 3x plus 2. Write 3a plus 2. All over x minus a. And the second method, you better have your factoring on point. Because this is a baby one, and there's still a little bit of factoring that goes on in it. Because your game is get rid of the x minus a in the bottom. That's creating the issue, because a minus a is equal to 0. So we write our limit as x tends towards a. We get rid of all of our parentheses. Travel it in, make sure to use that parenthesis. We love it. That way we can see that the numbers go away. It's like constants when you deal with derivatives. It's like constants just disappear. It's the strangest thing. The strangest thing. And then the limit is x tends towards a of 3x minus 3a all over x minus a. Can you see the factor? Can you see it? Can you see it? Can you see it? 3's on both of them. Factor that shit out to the front. Oh yeah, because we already know the damn answer, right? Isn't this the second time we're doing a problem that we did need to? All right, 3 over x minus a over x minus a. Hiya, hiya. That shit just goes away, leaving us with, yep, it's 3. 2 different methods for doing the same thing. I highly advise going towards method 1. But your online homework, it uses method 2 when it gives you an example. So, do you? I'm going to tackle something else. I'm going to call this g of x. Let's do this. This is going to be a much more challenging, a little bit more in the realm of maybe your homework. So let's call this 5x squared minus 2x plus 1. And we want to find g prime of a. Really, this is, if the g bothers you, like, look, it's just this. Huh? It's the same thing. It's just different pictures. Should I make it this and say it's smiley face of x and smiley face prime? They're just pictures. Don't be afraid of pictures. Just kind of figure out that there's a pattern to all this shit. So I'm just going to keep it as g and g prime. All right. Shut up and go. Shut up and go. I get sidetracked. I'm going to do method 1, which is telling us we're going to take the limit as h tends towards 0. This is our g prime of a equals this. Equal the limit as h tends towards 0 of g of a plus h minus g of a all over h. Now this is going to get quite dense as far as algebraically, but I have my intermediate algebra students doing these problems and they can get them, so I'm sure you can too, since you've already passed at least a class past that. Or you couldn't have been here. Now let's go through and replace in. I'm not going to show all the steps I did before. G of a plus h, that's all that's saying is we're going to plug an a plus h in everywhere we see an x. Now this is going to be very long. So we're going to say 5 times something squared minus 2 times something plus 1. Right? I'm just not writing it. Now that a plus h goes in. A plus h. I'm going to put a bracket around it because we're not done yet. Oh, don't do that. Come on. Now we're just going to find our g of a. So now instead of plugging in a plus h, we're just plugging in a, and that makes it 5a squared minus 2a plus 1. All right. Game. Get rid of all of your frickin' parentheses. All of them. It looks terrible right now. But this is where calculus students, you're supposed to know how to do shit like this. This is the level you're supposed to be at. Walking into the class, you should be able to do algebra like this. So a plus h all squared, that's a squared plus 2ah plus h squared. I'm not showing that. Just write it twice. A plus h times a plus h and FOIL. And FOIL. Minus 2a minus 2h plus 1. Bring our negative through. Bring your negative through. Minus 5a squared plus 2a minus 1. Shoot, we still got to bring all this in. Is your hand hurting yet if you're following along with me? Because I'll give you a problem like this, and this is one of the ones I'm going to have you write down. On your exam, where you're going to have a written portion, these are the types of problems you're going to have to be able to run me through with the algebra. Not just something on a computer. I'm actually going to want to see this. So bear that in mind. Especially if you have like secret tricks for finding these derivatives, like you've seen derivatives before. Whew! Got it all expanded out now. Gosh, I was trying to get your mind off of it by talking a lot. But plus 1, minus 1. Plus 2a, minus 2a. Minus 5a squared, positive 5a squared. It's like this shit's cooked up or something. You know what I mean? It's like it's all cooked up. Like everything goes away and the only thing left, h's, h's, and h's. Everything's got h's up top. If that doesn't happen, you've done something wrong. Go back. It happens every time like this. It's a game that's cooked up. We're trying to get rid of the h in the bottom, so let's factor out the h's from the top. It tends towards 0 up. So we bring an h out, and that leaves us with 10a plus 5h minus 2 all over h. Hiya, hiya. Cancel that shit out. Please, please don't do this. Don't do that. You're better than that. You're better than that. Don't do it. Sometimes it'll like be at the wrong place at the wrong time, and it looks like you want to cross it out. You've got to factor that shit first. So we're left with the limit as h tends towards 0 of 10a plus 5h minus 2. There's no denominator, so there's no problem. Let's just plug in our 0, and we see that we get, oops, let's put an equal sign, 10a plus 5 times 0 minus 2. So our answer is 10a minus 2. There it is. I'll be just anxiously looking forward to seeing your work to do this on your first exam when you write it down, and I gotta see you do all this stuff. Now when we go into this next section, here's the difference. Here's just going to be the difference. It's going to ask you to find this. We're going to call a x, and it's going to create a whole new function. So we would have found out that our new function would have been this, 10x minus 2. We'd say g prime of x is equal to 10x minus 2. And there's going to be a shitload of meaning behind that. We're going to play around with that, and that's going to be, big thing. So I will see you in the next one. We'll do some velocity, and then we'll be off to 2.8.